All right, this is Geometry Pace 1110. We're on page 39, looking at proof number 6. We're told to prove that angle A.C.E is congruent to angle D.E.B, and this is the drawing they've given you. Now this is the section of the pace where we're supposed to focus on redrawing what they've given you and splitting the triangles out, making them separate. So that would be your first thing to do. So look at the drawing that is given, and look at the triangles that we're supposed to be thinking about. We have triangle A, B, C right here. ABC is right there. And then you can see this other triangle, DBE, is right there with it. So we would redraw triangle ABC separately. And then I could take this one and put it down here. Maybe like that. So DEB and ACB. Notice something as you've done that though. Don't miss that they both share this angle here in common. And there it is, B and B. What we were given is AB perpendicular to BD. So AB perpendicular to BD, right there. We're also given that AB is congruent to DB. And that we can go ahead and mark. AB congruent to DB. We've also been given that AC is congruent to DE. We can mark that. AC congruent to DE. Always mark your drawings. So redraw these triangles, separate them out, and then mark the congruent sides. When you're looking to prove triangles are congruent, always start with the sides first, and then if you can't prove a third side or a second side, then start looking for angles. What's my reason number 1? Always given. Statement number 2. Well, we're trying to get to prove this. Let's look at our given and see what do we need to do next. If we have AB perpendicular to BD, then we should be able to say that angle ABC, let's write it here. Angle ABC is what? Angle ABC and angle DBE and angle DBE are right angles. Why? Definition of perpendicular lines. That tells me we have right angles. If we have right angles, then we should be able to prove right triangles. So that means triangle ABC and triangle DBE are right triangles. And what's my reason for that? Definition of right triangles. Does that make sense? If we have perpendicular lines, then the definition of perpendicular lines tells us that forms a 90-degree angle, which is a right angle. So we look at the angles that we were given and we can determine angle ABC and angle DBE. Now, how do I get DBE as a right angle? Well, really, this is the angle that's the right angle from our original drawing. But B, that vertex appears in both of the new triangles that we created. So if I'm looking at this triangle, then I see that angle here is a right angle. And that's DBE, which we wrote here. Angle ABC, right there, was a part of the original drawing right here. Also a right angle. which makes that right angle right there. And we wrote it here, angle ABC. Those are both right angles. We would have proved that through the definition of perpendicular lines. When you have definition of perpendicular lines and right angles, the next step you always want to jump to is proving you have right triangles, which we did. Triangle ABC, this one, and triangle DBE, this one, are right triangles by definition of right triangles. What do we do next? Well, let's look and see what we have. We know that we have right triangles. So we could even over here write, I'm running out of room a little bit, but as you are writing your proofs out, mark in the proof, either on the reason side or the statement side or somewhere here where it makes sense, what you know. We know that we have right triangles. So I'm writing the abbreviation for right triangles in parentheses right here next to the statement where I proved that. Now that I have right triangles, I can look for things like hypotenuse, leg, angles that I've proven are already congruent. That might be a hypotenuse or a leg in my new right triangle. So let's look back. AB congruent to DB. So AB congruent to DB, is that a leg or a hypotenuse in my right triangle? It's a leg. So I could mark leg right there. That could be either the leg-leg theorem or the hypotenuse-leg theorem to prove my right triangle is congruent. Well, let's see what else we know. I look back at my right triangles. I see my right angles. The side opposite the right angle is the hypotenuse. And we see we've already marked those as congruent. So let's go back and see where we knew that. AC congruent to DE. That's my hypotenuse right there. So I know I have right triangles congruent. I know I have a hypotenuse and a leg that I've already proven congruent. That means in step 4, using my hypotenuse leg theorem, I can say what? That my triangles A, B, C congruent to triangle D, B, E. I just proved this triangle congruent to that triangle. When we prove two triangles are congruent, that unlocks CPCTC. It's like you've got that next level. Now you can use that tool. You reach in, pull that tool out of your toolkit, and say, where can I apply CPCTC to help me? Well, let's see. Can we use that anywhere? Only have one more step, according to the pace. Am I ready to say angle ACB is congruent to angle DEB? Let's look. Maybe CPCTC, CPCTC, say that, CPCTC. Maybe that will help me to be able to prove my final statement. Let's look. ACB, where is this? ACB. That's that angle right there. Is that part of the right triangle? It is. That's congruent to this right triangle. Let's see if they line up. Really, I'm looking at now this angle, DEB. E is the vertex, that angle. Am I ready to say that this and this are congruent? I am, because I've already proven these two triangles are congruent. Therefore, these are corresponding angles. If I were to take this triangle and sort of flip it around, it would sit right on top of this one, and that angle would line up with that one. So I'm ready to say angle ACB congruent to angle DEB, and the reason is CPCTC. That finishes problem number 6 on page 39.